Note to the production team, I know that the visible area here includes some desk down here at the bottom, but you'll see in a moment that the screen will, or I'm going to add another sheet of paper here for which I need all of the visible screen. So if you want to figure out a way to cut and paste and get rid of all that, that's up to you. Yet one more plot that we can take a look at that gives useful information to us beyond the box plots, beyond the histograms, beyond even a stem and leaf type of diagram, is the time series plot. It's very easy to end up losing sight of a bigger picture here when you start getting immersed in quantitative kinds of information. And one of the things that you can lose sight of is that if data comes to you in any sort of a time-related sense, or a sequence, or it's a function of space, if any of those are somehow a potential factor in what's going on in the process, then you need to always be thinking about, in essence, like a scatter plot or a time history type of plot. So if you're looking at, say, the length that of a part that a piece of equipment is producing, to measure that length in a regular fashion over time can be very useful to begin to detect trends if the piece of equipment is going out of calibration. For instance, this is a time series plot that is related to the testing of some aluminum pieces. It's a compression strength history that's being plotted. And if you were to only look at the stem and leaf information over here on the left, well, you get a nice kind of idea that, gee, there's a normal-like shape to the distribution. It's relatively symmetric. It's centered probably somewhere between here. This 15 stem is likely related to the mode or the peak. It might be somewhere in between here. And that's all great information, but it doesn't relate or tell us anything about how, say, this data point relates to this one or that one, so on and so forth. And so if there is the potential that time is somehow important, and it might be in the production of, say, aluminum ingots or some sort of particular material over time, as you're manufacturing that piece, the pieces of equipment may change and alter. So let's go back and look at the time history. Now, this particular set of data seems to have quite every once in a while some big large outliers, high and low. If we got rid of those and only looked at the data that's in between, you might think that there is a general trend downwards. And that's one of the things, if I'm just eyeballing here a line that might go through some sort of middle, and we'll talk later on in other modules about how you actually create such a line that minimizes the squared error between the line and the data point. In other words, linear regression. Right? If there is indeed some sort of downward trend, it might be indicative that the piece of equipment is somehow going out of calibration, or there's something else going on in the development of the material itself that is influencing whatever property it is that we're measuring. And that's why we don't want to lose sight that if there is at all a potential time factor or a sequence just might mean that it happens at this point and then this point and then that point. It doesn't have to be time as in seconds and minutes necessarily related. That you always want to go back and look at the data somehow in that kind of fashion and see if there are any discernible trends that can be picked up. Trends that you're just simply not going to get out of the stem and leaf plot, or the histogram, or the quantitative measures of average, or spread, or kurtosis, or symmetry, or any of those sorts of things. Hence, people have invented such things as well, the moving average, and other sorts of quantitative ways to measure what that trend might be if such a one exists. And we'll get into that more later on, but from a big picture standpoint of statistical quality control, those are the kinds of things you begin to take a look at, and that time sequence is very important. Now, this particular figure that you see here, and again, this is directly out of your text, figure 617, you've got both the stem and leaf plot right next to the time series plot. When that happens, they're sometimes called Digi plots or digidot plots. There's nothing particularly all that special about them other than that they're just very convenient to see this summary information over here. It could have been a histogram. It just turns out to be easier to produce the stem and leaf plot right next door to the time series plot. Minitab makes this very easy and simple to do. It's not so simple to do in, say, in Excel, but you can certainly get the information out of there, and if you do a lot of work, you can in Excel you can put that together. Other statistical packages that are out there, some of which are freely available, others of which, of course, you have to pay for, can do the same sorts of things. Very handy, useful kind of tools, especially for trying to get a sense of what might be happening simply at a glance. And then if you think that there might be an issue, you can go and take a look at more of the quantitative measures to understand what might be going on. When we talk about control charts, we will be getting into just another version of the slightly different version of what we see here.